So I put this example down as a complex unfamiliar. Numerically it's not too bad. The unfamiliar aspect comes later in the question, but it's probably an easier complex unfamiliar than you might get. So I don't want you to look at this and think, oh, that wasn't too bad, the entire exam is going to be easy. I think this is probably, for me personally, I think it's on the easy side of the complex unfamiliar section. It's complex because there's multiple processes. It's unfamiliar because there is an element in summing sequences that you haven't done before as part of this question. So I'm just going to zoom in a little bit and we can do some work into the side. So we've got two series first of all. We've got Daniel and we've got Lisa. And what I might do is actually, let's assume that you aren't quite sure how to approach this. The best way to go about it would be to start playing with the sequences. So Daniel to start with, if I put down some dates, not many, but 1, 2, 3, 4, 5, and Daniel's sequence will look like this. On the first day he does 10, on the second day he does 12, then he does 14, then he does 16, then he does 18, so on and so forth. Whereas Lisa's sequence, on the 5th of January, which is there, she does the same number of push-ups as Daniel. So she does 18 on the 5th of January. But on the 9th of January, she does 4 more push-ups than Daniel. So you could actually determine Daniel's 9th of January quite easily and then work out Lisa's sequence from that, which will work quite nicely. But now I've got a bit of an idea of where I'm heading. What I might do is set up Daniel's Tn equation. I want this to be a well-worked solution. So I'm going to set up Daniel's nth term equation, find his 5th day stats and his 9th day stats, and then use that to determine Lisa's situation. So let's start with Daniel. Now that I've got a bit of an idea and I've got that little diagram there. Daniel's Tn situation is that on the 1st of January, which is term 1, is 10, and term 5 is 18. We also know that D equals 2, so we've got an abundance of information about Daniel. We worked out term 5 from that. D is 2, T1 is 10, so Tn is equal to 10 plus, actually I've got D there, so let me rub that out, 2 n minus 1. That's Daniel's nth term, using the A plus n minus 1 D. I know D and I know A. So I've got Daniel's, which means I can work out T5 is equal to 10 plus 2 times 4, which equals 18, and I'm going to use that piece of information. And I also know that T9 is equal to 10 plus 2 times 8, which equals 26, so I'm going to be needing that piece of information as well. So that's all that's important at the moment from Daniel's. From Lisa's, I know this. I know that her T5 is equal to 18 because she does the same number of push-ups as Daniel on day 5. And I know that her T9 is equal to 26 plus 4 because she does 4 more push-ups than Daniel on the 9th day. Everybody happy with that? And that's all the information out of the question now. So that's equal to 30. So I now know that Lisa's situation looks like this. 1, 2, 3, 4, 18, 6th, 7th, 8th, 9th. That's Lisa's situation. What I want to do is determine what Lisa's nth term equation is so that I can find her first 10 days as well, and we're going to do a sum and work out where we're at. So Lisa's nth term, Tn, is equal to T1 or A plus n minus 1 D. And I know her term 5. Term 5 means 18 is equal to T1 plus 5 minus 1D, which is T1 plus 4D. And again, this is that simultaneous equations approach, but you would be more than welcome to just do an approach where you go, what number am I doing? Plus what, plus what, plus what, plus what? What number do I add 4 times to get from 18 to 30? You could do something more logical like that, but I'm going to stick with this just to show you how to do it a really technically nice way that will always work. 30 is equal to T1 plus 9 minus 1D, which equals T1 plus 8D. This is equation 1 and this is equation 2. And now if I do equation 2 minus equation 1, I get 30 minus 18 is 12. I get T1 minus T1 cancels out. I get 8D minus 4D is 4D. and therefore for Lisa, D is 3, which contextually means that she's adding 3 push-ups per day, whereas Daniel's only adding 2 push-ups per day. So we've got that information now. If D is 3, then I know that 18 is equal to T1 plus 4 times 3, and therefore T1 is equal to 6. So on the first day, Lisa does 8 push-ups. Everybody happy with that so far? That's the technical way of doing it in simultaneous equations. You don't have to do it like that, but I encourage you to learn how to do it like that, because if we give you a question that has 392 and 2081, it could get a bit more out of hand to do it using a logical method. So I'll just scoot down here to finish this question off. Now this is the bit where we get the unfamiliar. If anybody who sat through math methods in term 1 last year might remember that there are equations for summing a sequence, an arithmetic or a geometric sequence that we'll get to. In general, you don't need to know those equations. There's no expectation that you'll be able to use them or that you're aware of them. You might get a question like this though. If you do, the sum will be very doable. In this case, it's 10 terms and you would have a calculator. So all I'm going to do now is the sum of 10 days for Daniel. I'm going to write down his first 10 days. So his first 10 days, he starts at 10 and then he adds 2 every day. I've got all this information now. Plus 20, 22, plus 24, 26, plus 28. If anybody'd like to add that up for me, you're welcome to. It's 150, I think it's 190, but you might want to just check.
Yeah, it is.
Is it? Okay, cool. And Lisa she starts at 6 and then she adds 3 each time. So 6 plus 9 plus 12 plus 15 plus 18, 21, 24, 27, 30, and just make sure I get the terms right, 33. And that will be equal to 195. You got what, sorry? I feel like it's 195.
Yeah, it is. Sorry.
And so then therefore, Lisa does more by 5 push-ups. Now obviously if we then transcend this forward, Lisa's now ahead of Daniel, and for the rest of the year she's going to stay considerably ahead of Daniel. But unfortunately for her, on the last day of the year, she will be doing 3 times 365 plus 6, or 3 times 364 plus 6 push-ups, which I think is maybe a little bit out of hand, but nonetheless, that's her problem. Any questions on that? Complex unfamiliar in particular, but really most of the questions that have got context, go back and read the question, make sure you've actually answered it. In the first 10 days, who does the most? We did that. And by how many? We did that. So we've answered the question, we should get complete marks. It's not necessarily always true, but expect if you're dealing with a complex unfamiliar question that you're going to end up with, it should be multi-process question to be complex. You should see you've got a fair bit of working in there. There's going to be multiple steps you're taking. So finally, can you apply arithmetic sequences to known and unknown contexts for a range of problems? That's the question, that's the success criteria. You answer that yourself, either now or after you've done some work in the exercise. The exercise is 4D, and I'm going to leave you to it for the rest of the lesson.